Dear students, in this video we will see the categories or classification of arrays or types of arrays. Arrays are mainly categorized or divided into two types. First type of array is a single dimensional array, or it is also called as one dimensional array. Second category is a multi-dimensional array. Its name itself is a multi. It means that it is more than one. So here it may be two-dimensional array, or it may be three-dimensional array, and so on. In our syllabus we have only one-dimensional array and two-dimensional array. We use three-dimensional array or four-dimensional arrays only in complicated or complex problems. In simple problems we use only one-dimensional array and two-dimensional array. So first we will study one-dimensional array. This single dimensional or one dimensional array is nothing but it is a linear or continuous list which contains the same type of values. So as I already told, it is a single dimensional array. It means that all memory location, you just imagine that they are one beside the another. It means it is just like one x-axis, and the first location is a of 0, second location is a of 1, third location is a of 2, fourth location is a of 3, and so on. In the first location, whatever the value you want, you can put it, but if it is a integer array, you can put only integer value. In second location also, in third location also, in all locations in a complete array you can store only integer values. If it is a floating point array, then you can store all floating point values. So single dimensional array is basically it is a linear list which contains same type of values. Multi-dimensional arrays are again classified into many number of types. As I already told, the multi-dimensional arrays may be two-dimensional arrays, three-dimensional arrays, or four-dimensional arrays, and so on. And it may be n-dimensional array. So we use these one-dimensional array and two-dimensional arrays more frequently in our problems or applications. Only some applications need higher dimensional arrays like three-dimensional or four-dimensional. And these dimension we are telling. So this dimensionality, how we can find out dimensionality of an array can be determined, or we can find out by just simply observing the declaration of that array. So in that declaration of that array, if there are one index after the name of array, then we can simply say that it is one dimensional array. If there are two indices, the plural of index is indices, or two indices or two subscripts, then we can say that it is a two-dimensional array. For example, the array is like this, that is a of I. The I is written in square bracket. Okay, so by looking into this array variable, easily we can say that it is one dimensional array. Second example is here, that is a of I and j. So since there are two indices are there, so or two subscripts are there, one is I and another one is j, so this is called as two-dimensional array. Now we will look into declaration of one dimensional array, how to declare one dimensional array. Okay, just to focus on only one dimensional array now. In future, in the next videos, we will see the two-dimensional arrays. So declaration of one dimensional array, as already told in module number 1, so declaration is nothing but reserving the amount of memory. Reserving the amount of memory is nothing but declaration. Declaration of one dimensional array, it means that you are introducing the array name to your compiler before using that array in your program. In my program, I am going to use this array name. You are informing this fact to compiler. That is declaration, or reserving the amount of memory for the array. And the syntax to declare the one-dimensional array is like this: data type, give one space, you write array name. Array name is nothing but it may be any valid identifier or variable name. As already told in first module, we have to follow some rules to write the identifiers or variables. Same rules we can use here. Array name is nothing but it is just like a variable name, and immediately after the variable name, inside a square bracket, set of square bracket, we have to mention or specify the size of that array. Size of that array is nothing but, size is nothing but here how many elements or how many values that array can store. It means that that is the capacity of that array. So after that, compulsorily, mandatorily, we should put a semicolon. So once again I repeat the syntax: data type followed by a space followed by a array name, immediately followed by a array size in a set of rectangle brackets or square brackets, then put a semicolon. Here data type is nothing but it is a basic data type, array name is nothing but it is a valid identifier as I just now I told you, and size is nothing but it is a number of values an array can store, and the size must be an integer constant. So always size will be or should be integer constant. It should not be a floating point constant like 2.5, 4.5, not like that. It should be only 2 or 4, so which are integer values. It means that an array can store 2 values, an array can store 4 values. Okay, and that integers array size must be specified within a pair of square brackets, and a semicolon should be present at the end of the declaration line. First index or first subscript of that array is 0. For example, that is a of n. Here n is nothing but it is indicating one integer value to represent the index of that array. Okay, index of that first element. So first index of an array is 0, so that will be a of 0. Last index or last subscript of an array will be it is always one value less than the total size of that array. It means that suppose the array size is 5, then size less than 1 less than the size. It means that 5 minus 1, 5 minus 1 is 4, so last subscript of that array will be a of 4. So if the size of array is 25, the first element or first subscript or first index will be a of 0, and last index or last subscript will be a of 24. So always index starts from the 0. So here last index will be always one value less than the total size of that array. Example is here int a of 5. It means that a is a array name, and instead of a you can take any valid identifier or variable name. Here I have just taken it as a. Okay, so here I declared this array variable as int a of 5 semicolon. Instead of this square bracket and 5, if I just like this int a semicolon, then it will be primitive data type. So it means that it is a simple ordinary variable. It means that a is a integer variable which can store only single value. But here what I am doing, here after int I am giving one space, and after that I have written one valid identifier array name. After that I have written size of array in square brackets. So once you use square brackets after the immediate name of variable, then it becomes array variable. It means that it is non-primitive data structure or data type or a variable which can store multiple number of values, not only single value. Here the capacity of this array a is 5. It means that it can store or hold 5 values. So here first index of this array will be a of 0, and last index of this array will be a of 4. So a of 0 is indicating first location, a of 1 is indicating second location, a of 2 is indicating third location, a of 3 is indicating fourth location, a of 4 is indicating last location, that is a fifth location. So since here we are declaring this array a as int, you can store only integer values in this blank memory locations. Okay. Next we will see initialization of one-dimensional array. Initialization means, as I already told, in the declaration line only, if you are assigning any values to these array, then it is called as initialization of one-dimensional array. Initialization is a process of assigning or giving the value to a variable. So in normal variables, in first module I already told you, int a is equal to 2. It means that we are using one assignment operator equal. It means that the associativity of this equal is always from right to left. It means that 2 is assigned to a, 3 is assigned to b, and sum is not assigned any value here. We have to calculate the value of sum. We means we have to use our brain and we have to write the logic to find out the sum in the program. It means that our program should give us the result or sum. So here we cannot write the value of sum. We can just assigning the values for two variables a and b. First variable value is 2, second variable value is 3. This is the case where we are declaring normal ordinary variables, but in case of array variables we should use square brackets to specify the size of that array. So here after a I have not used any square bracket, after b I have not used any square bracket. So these variables are normal or ordinary variables. So like initialization to ordinary variables, the individual values of that of an array can be initialized either in declaration part or in execution part of the program. In first module I told you we can use actually three methods. First method is we can initialize the values in declaration section only, so that is assigning the values to variables in declaration section. And second method was we can assign the values to variables in execution section. And in execution section only, again there are two methods are there. First method is by using input function, that is scanf, or else one more method is there, that is by without using a data type, directly we can assign the values to variables. Same thing here also we can do. So here also we can assign the values to array in a declaration part or else in the execution part by using a scanf function. If we initialize them in execution part, then we must use a standard input function, that is scanf, in a for loop. Simply we cannot use a scanf function here. That scanf function should be present inside a for loop. Why sir we should use a for loop? Because here in first module whenever or in second module whenever we wanted to enter any values, we just used one printf statement. There in printf statement we had written enter the values of a and b. So after that immediately we had written scanf. So scanf %d ampersand a comma ampersand b we had written. Here only one variable value, a variable value, and one more variable value b we are passing there. But here we are in array variables there are multiple number of values are there, not a single value. So to read these many number of values, so just wait, I give one more example, you get confusion. In the program of to find the area of a circle, there we use one printf statement, that is printf enter the value of radius. Here to calculate the value of area of a circle, only radius is enough. If you know the value of radius, easily you can find out the area of circle by using the formula pi r square. So pi value is a standard value or constant, that is 3.142, and r value you don't know. So r value if you enter by using input device keyboard, then it is sufficient to calculate the area. So here also when we use in that program printf statement, that is enter the value of radius, we read or we enter the value of radius with the help of standard input function, that is scanf percentage d if it is radius is declared as int, percentage f if that radius is declared as float, percentage f comma ampersand r or ampersand radius, right? So here only one value you are reading, so you are not using this scanf function inside a for loop. Directly you used scanf function after the printf function. But here in arrays, whenever we want to enter multiple number of values inside that array, we should put or we should use this scanf function always in a for loop. Keep it in your mind. Whenever you are going to enter the values of an array, you should use a scanf function inside the for loop, because we are going to enter multiple number of values for each and every value. To read that each and every value, one iteration will be executed, one iteration of for loop will be executed. Similarly, if you want to write or if you want to print the elements of an array on a monitor screen, you should use a printf statement compulsorily inside a for loop. One by one all the elements will be accessed and it will be printed on a monitor screen. So here, since multiple number of values are present in an array, multiple iterations of or multiple number of loops of a for loop is required there. Initialization of one-dimensional array in declaration part. See here the syntax of initialization of one-dimensional array: data type space array name size is equal to in flower brackets, or else it is better to call them as braces. Inside the braces, value 1 comma value 2 and so on up to value number n. Okay, and at last we should put a semicolon. Here data type is a basic data type, array name is a valid identifier, size is a maximum number of values in the array, and values is nothing but here values must be enclosed within a pair of curly braces and they must be separated by a comma, and at the end of the declaration statement a semicolon should be present. So here some examples I have written for initialization of one-dimensional array. First example is int a of 5 is equal to inside a braces 26315 semicolon. It means that since the size of an array a is 5, I can store only maximum 5 elements or 5 values in that array. I cannot store sixth value. So you please remember, you just look at this structure, data structure or memory locations, how these datas will be stored in a memory. So these array size is 5, so first index will be obviously a of 0, last index will be a of 4, that is 4, that is one less than the size of that array. So a of 0 is index which is indexing or pointing or addressing the first location of that array. A of 1 is addressing a second location, a of 2 is addressing third location, a of 3 is addressing fourth location, a of 4 is addressing fifth location. So maximum I can store 5 values in this array. I cannot store a sixth value in the index a of 5. Okay, and second example is also int a of 5. Here instead of storing 5 values, I am storing only 2 values. Here one is 2 and comma 6. So since I am declaring that array as an integer, so by default 5 locations will be allocated for this array name. That array name is a, but since I am storing only 2 values, first value will be stored in the first location, second value will be stored in second location consecutively, and the remaining last 3 locations will be by default those locations will be stored as 0 or stored with null values or 0 values. Okay. In example number 2, compiler sets 0 to all uninitialized values because size of an array is 5, but there are only 2 values in the array, and number of values should be always equal to the size of the array. This you should keep in your mind always. The number of size of the array should be equal to number of values, or number of values should be equal to size of the array. Suppose if the size of the array is 5, you cannot store 6 or 7 values there. You can store only 5 values. Okay, the number of values should be less than the size of the array. So or else the number of values should be less than the size of the array. If the size of the array is 5, so number of values 2 is also okay, 3 is also okay, 4 is also okay, and even 5 is also okay, but number of values should not exceed 5. It means 6 values or 7 values we cannot store here, but the number of values cannot be greater than the size of the array. So the main point is here, the number of values what you want to store in that array should be equal to or less than the size of that array. The number of values what you want to store in that array should not be greater than size of the array. Okay. Reading and printing the values of one dimensional array. Only 3 steps are, my dear friends, very simple steps. Step 1, I think you understood what is the topic here, that is reading and printing the values of one dimensional array. One dimensional array is there, and if initially it is empty, one by one you want to enter the values, or you want to store the values, or you want to store the elements in that array. How to insert or store those values? Just now I told you, the only way is you have to use one standard input function scanf within the for loop, and printing the values of one dimensional array. One dimensional array is already declared, and already values are also stored in that one dimensional array. Now just from memory I want to display it, I want to take it and I want to display it on a monitor screen. Again here, to print or to write the values on monitor screen, we have to use one standard output function, that is printf function inside a for loop again, because we are not writing only single value, we are writing multiple number of values on monitor screen. So first step is declare one dimensional array with its size. That size is nothing but number of values. And step 2 is read every value into an array using a standard input function, that is scanf function. As I already told, this scanf function should be within a for loop. And third step is, if you want to print those values on a monitor screen, print every value from that array by using one standard output function, printf function, within a for loop. So here one simple program example is there. Program to read and print the values. Hash include stdio.h int I, which is very essential whenever we use array programs to represent the index of that array. And n is nothing but how many number of values you want to store in that array. Of course already you know that your array size is 20, a of 20 here. It means that array a can store maximum 20 values, but if you do not want to use all those 20 locations, if you have only 5 values or 4 values, ultimately how many number of values you are going to store in that array? To represent that one, we need one more variable, that is n. And last I am declaring one array variable a with the size 20. Okay. Void main, open the main function, then clear screen, printf, enter the number of elements, or enter the number of values, how many number of values you want to enter, then scanf, that is %d ampersand n. Okay. Printf, enter the values one by one. Okay. So now suppose if you want to enter 5 values, even though that array capacity is 20, you want to enter only 5 values, so those n value will be 5. Now you enter those 5 values one by one from your keyboard. Enter the values one by one by using scanf function. Scanf function should be inside a for loop. So for I is equal to 0. Here remember, I is nothing but index. I is initialized to 0. So a of a of 0. If I value is 0, it means that a of 0. A of 0 is nothing but it is indicating or addressing first location or first um, uh, memory space of that array. So I is equal to 0. I is less than n value you had given 5, so up to fifth look in the index, this for loop will be keep on iterating, then I plus plus. Okay, instead of writing this for loop like this, you can write this for loop like this also. With pencil I have written here, that is for I is equal to 0 semicolon I is less than or equal to n minus 1 also you can write. Just feel the difference here. Here I had written only I is less than n, but here this side I have written I is less than or equal to n minus 1. That also acceptable. And last condition, increment is I plus plus. Then now start reading the values one by one from the keyboard. Whenever you presses the buttons from the keyboard, these values will be entered into the array. So this for loop is opening here. Inside that for loop, one scanf function is there, percentage d ampersand ampersand a we write only when we want to read a value for a simple or ordinary variable, but it is not ordinary variable, it is array variable. So simply we cannot write ampersand a, we should write ampersand a of I. It means that along with that array name we should write its index also, then put a semicolon and close the for loop. Since here inside this for loop there is only one statement is there, there are not a group of statements, we can remove these opening brace and closing brace also, no problem. Okay, then printf. So whatever the values you stored, now you start printing them on a monitor screen. Print the values stored in that array are, again you use a printf function inside the for loop. This time you are printing the values on monitor screen, you are not reading the values from keyboard, so you use a standard output function, that is printf should be present in a for loop. For I is equal to 0, I is less than n, I plus plus, or else I is equal to 0, I is less than or equal to n minus 1, I plus plus. So here printf is a of percentage d. A of percentage d is equal to a of percentage d. A of percentage d is equal to percentage d slash n. Since a slash n is there, one by one all the elements of that array will be displayed in one by one in 5 lines if you have entered n value as 5. And first percentage d is nothing but value of I, second percentage d is nothing but value of a of I. Then close the for loop. If you are not using a multiple number of statements inside the for loop, you can remove this opening brace and closing brace also. At last you close the main function with a closing brace. Okay, here one more example is there. Program to add the corresponding elements of two arrays and to store the sum in a third array. In first module you have already written one program to add two numbers a, b and sum. Three variables you had declared there. A value you will give, b value also you will give, but your program should give you the value of sum. Similarly here, instead of adding only two values, here entire arrays are going to be added. Entire the elements of arrays are going to be added. So one array I will take it as a, second array I will take it as b, third array again I will take it as a sum. So here instead of declaring them as a single or simple or ordinary variable, we are declaring them as array variables. You just look at this program. Include stdio.h int a of 20 comma b of 20 comma sum of 20, and as usual for indexing purpose I need one more variable, that is I, and to store or to represent how many number of values I am going to store in that array, I need one more variable, that is n. Open the main function, you print one statement there, enter the number of elements in A and B. So equal number of values you should enter here, because the corresponding elements you are adding here. Okay, so scanf %d ampersand n. It means that the question is here, a in first element of A array, whatever the value it may be, it should be added with the first element of B array, and the result should be stored in the first element of some array. Okay, so second element of A array should be added with the second array second element of B array, and the result should be stored in the second element or second location of some array, and so on. So here first enter the number of elements in array A and array B. That is you are just entering the value of n here, that is %d, and enter the elements of array A. So one by one you read the values of A. For I is equal to 0, I is less than n, I plus plus, scanf %d ampersand capital A of I. Instead of small letter a, you can observe here I have written it as capital A, because it is valid identifier. Whatever you want you can take it here, no problem. And printf, enter the elements of B array. Again same steps. For I equal to 0, I is less than n, I plus plus, scanf %d ampersand B of I. Now you have read the values of A array and the values of B array. Now you start adding the corresponding elements of these two arrays. So for adding, again you are not adding only two numbers, you are adding multiple numbers. Okay, so again you have to do this sum step inside a for loop. Again, for I is equal to 0, I is less than n, I plus plus, sum of I is equal to A of I plus B of I, close the for loop. Now we have to put these values, whatever the sum value we are getting, we have to put them in a first location of some array, second location of some array, third location of some array, and so on. So here sum of elements of A and B are, again we have to this time we are going to print it. So we are going to use one of standard output function, that is printf inside a for loop. For I is equal to 0, I is less than n, I plus plus, printf %d slash n, or also you can use slash t also, and the variable is sum of I, and close the main function. And here next example is we are going to find out the biggest of 10 numbers. In first module you have already written one program to find out the biggest of 2 numbers and biggest of 3 numbers. But here if the numbers are more than 3, like 4 numbers, 5 numbers, 10 numbers, 100 numbers, 200 numbers, 1000 numbers, 2000 numbers, then ultimately we have to use one powerful data structure to store these all values, that is array. Okay, hash include stdio.h int I comma n a of 10, or you can take it as 20 also, since we are going to find out biggest of 10 numbers. Here I mentioned the size as a 10. If you mention it as a 20 also, no problem. If you mention it as a 20 in our program, we have to add one more line or statement, that is enter the value of n. Then n value should be 10. Okay, and one more value I want, that is biggest. So among those all 10 values, which one is the biggest? To store that value I need one more variable, that is the biggest, and open the main function, printf, enter the size of an array, that is n value it is asking, scanf %d ampersand n. Once you enter the value of n, enter the elements, that many number of elements, that many number of values in that array by using a for loop. For I equal to 0, I is less than n, I plus plus, scanf %d ampersand a of I. And once you read all the elements in that array, you initially think that biggest value is present in first location itself only. So in the comment line I have written here, assume that a of 0 is itself is a biggest. So what I am doing here, a of 0 is equal to biggest, or biggest is equal to a of 0. Since it is an assignment statement, so a of 0 is an index. In this index, whatever the value is there, integer value, so because a is an integer array, so integer value will be there obviously, so that integer value will be assigned to biggest variable. Then after that, the logic is here, for I is equal to 1, it means that now the index starts from 1, because already first index is we have assumed that it is a biggest number. Okay, whether it is true or false, it is we will look it into later, but first we will believe that first value itself is a biggest value. Now we will keep on comparing this biggest value with the next index, and again if it is a the first index value is really biggest, then we have to print it as a biggest number, no problem. So if it is not biggest, then we should print that second location value, or second location element is biggest. Like this, whenever we get the biggest value, we should be keep on comparing that biggest value with its next indexed value in that array. So this is the main logic of this program. So we will start this comparison from the index number 1. So for I is equal to 1, I is less than an I plus plus. If a of I is greater than biggest value, a of I is here, I is already I know that is value of I is 1. It means that the second location value, if it is greater than biggest, then biggest value will be what, obviously a of I only. Then close this if condition, and also close this for condition. So here for loop, so this comparison and initialization of value to this biggest variable will be keep on executing till this I value will become 10. Okay, once this I value becomes 10, 10 is less than 10, then that condition will become false in that for loop. Then that control comes out of the for loop, and finally you will get the biggest number among these all 10 numbers. Printf biggest number is equal to percentage d. Okay, so that percentage d is nothing but the value of the variable biggest. Close the main function. Okay, so here based on these one dimensional array, we can execute these many number of program examples, searching for a specific element in an array, and merge the elements of two arrays into one array, and sorting of the values of the array either in ascending order or descending order, and finding sum of all elements of an array, etc., and counting the number of elements present in that array. These all are the other programming examples, so we can solve with the help of one dimensional array. In next class we will see two dimensional array.